All right. So standard deviation. Standard deviation is going to be a measure of how spread out the data is. So what does that mean? It's a measure of what? Remember from last time we had those two categories? It's going to be a measure of what? How spread out the data. What do we call that? Do you remember? Measure of disperse. Measure of dispersion. Measure of dispersion, as opposed to a measure of central tendency, which tells us where the what is. What's the measure of central tendency as opposed to one of these? Central tendency. Yeah, central tendency is where the middle is. Dispersion is how spread out it is, how clustered it is around that middle. So the bigger the standard deviation is, the more spread out the data is. Just like with range, the bigger the range was, the more spread out the data was. But this is much, much more accurate than a range. This is the formula right here. You don't really have to know the formula. I just put it up there just so you can see it. What you do have to remember is that the symbol for standard deviation, one of the symbols is going to be this. It's kind of like an O with a tail on it, sub x. I believe it's in the, is it in the book? The symbol for it? Yeah, it's in the book. So that's going to be our standard deviation. Now, fortunately, like I said, we don't have to memorize that formula. The calculator is going to be giving us a standard deviation. It's actually in that same readout where we found the mean and the quartiles, the median, and all that stuff we found yesterday. It's right in there. You just didn't know the symbol, so you kind of ignored it, I'm sure. So if we take a look, let's say we had these four numbers, 2, 4, 5, 9, and we wanted to find their standard deviation. All I'm going to do is exactly the same thing as when I found the median and the mean. Insert a list and spreadsheet. What is going on? You know, I'll call these values. And we had the numbers 2, 4, 5, and 9. Make sure when you're typing that in, just like I said yesterday, make sure you hit enter after every one, including the last one. Don't forget about that last one. And then we're going to go, oh, not a list and spreadsheet. We want to add a calculator page. Where do I go now? Menu. 6, statistics. First one, stat calculation. One variable. One list. Called it values. And we get our same readout as last time. Except this time we go, and we can find right here the standard deviation. We get 2.55 rounded to the nearest hundredth. Okay? And that's all it is. It's exactly the same as last time. You're just going to be looking at different things on this readout. So let's give it a shot. We can skip this problem. It's just another one with the 4. I think we can go on with that. So let's say we had king crabs. The weights of brown trout. So they captured 15 of them. And we want to know their weights accurate to the nearest hundredth of a pound. Okay? These are the 15. So go ahead, put that in a list and spreadsheet, and get out that data readout. We need to find the mean and standard deviation. All right. So I'm going to insert my list and spreadsheet. I got my weights. And somebody's done could read me off the numbers. 2.45, 1.6? What? 1.6, yeah. 1.53, 2.89, 2.85, 1.09, 1.23, 2.39, 2.97, 2.28, 1.79, 1.48, 62, 1.17, 1.41. Okay. Where am I going now? Add a calculator. Menu. 6, 1, 1. Okay. Weights, my variable, my x is going to be the weight. Don't need a frequency. And I get my readout. Okay. And what do I need to find? The mean and the standard deviation. Okay, so I symbolize mean how? X bar. Yep. X bar, bar X, X bar. And it is to the nearest hundredth. Make sure we round right. 1.92. 1.92 pounds. Don't forget your units if they're given them. And what's our standard deviation? 0.64. 0.64. Okay. Now we also needed to know, if you flip back, our part B to the question. Part B said determine the percent of brown trout that fall within one standard deviation of the mean. So we know our mean is 1.92 pounds and standard deviation 0.64 pounds. If I'm within one standard deviation of the mean, that means that I'm spread out no more than whatever the standard deviation is, more or less than the mean. So what is the maximum weight that I could have and still be within, would still be no more than above one standard deviation of the mean? How would I figure that out? What do you think? Huh? Well, subtracting will give me what? One standard deviation below the mean. So that's how I find below the mean. Here's the mean right here, x bar. Here's one standard deviation below it, x bar minus the standard deviation. X bar plus the standard deviation will give me one above, and this, huh? Yeah, you'll see it in a second. You'll see it in a second. Bear with me. So what is x minus the standard deviation? What is x bar minus the standard deviation? So you get 1.92 minus 0.64. 1.28. 1.28. And what is x bar plus the standard deviation? 2.56. So we have this range kind of. That's it. That's it. We have this range. Anything between 1.28 and 2.56 is within one standard deviation. That's what that means. Everybody kind of following? So how many of our values are within 1.28 and 2.56? Just go back to your page and count, literally count, You're the first one, 2.45. Yes, that is. That's 1. 1.6. Yes, that is. That's 2. How many did we get? How many do we get? Yep, we get 9 values that are between there. And we want to know the percentage. So how do you find a percent? You put what? 9 over 15, there are 15 values. 15 values. And 9 over 15, when we convert it to a percent, 60 comes up to 0.6, which is 60%. Yes. And that's the percent of trout that fall within 1 standard deviation. So when they say within a standard deviation, remember, just take the mean, subtract the standard deviation to get the low boundary, add a standard deviation to get the high boundary, and that's your range, and then you just got to count. Okay? It's not that bad. Something else we have to talk about. When we're doing statistics, remember, these are all about these, we've been saying, these studies, we're pulling trout out of a stream or whatever. We have a sample population, we have a sample mean and a population mean. We're going to use, it's always better to use the population. Population means I'm going to use the whole thing. So if I want to know, like, if students in this class, how many of you play a sport? You're my population. You're the only population I care about in this study, and I can just go through and I can ask you one by one. Do you play sport? Do you play sport? Do you play sport? Do you play sport? But if I want to know, like, how many students in second period classes in every classroom in New York State play a sport, I'm not going to go to every classroom and ask them that. They actually said it's mean, and then mean goes to standard deviation. It really doesn't matter which one you're doing. They're not going to? Okay. Okay, that's the next slide. But all right. They had both in there. I thought they both mattered. All right. All right. So see, in one study I used the sample, in one study I used the population. When you do that, you're going to get your calculations. We're going to symbolize standard deviation 2 different ways to show which one we used. If we use this symbol, this like kind of little O with a tail on it, sub x, that means we used the population. We used everybody that we were talking about. If we just use the sample standard deviation, we're just going to symbolize that with just an S sub x. Okay? And so now we have a little thing. For these 4 situations, figure out if it's better to use a population or sample standard deviation mean. All right? Just go through, try and answer those right now, and then we'll go over them. All right. So we worked through these a little bit. How about the average, if you want to figure out the average age of teachers in Frankfurt, you'd take a sample? How many teachers do you think there are in Frankfurt? 50, 60? Can't just go through and ask them? It's pretty private. They're all right here, right? I would probably go through and ask them. Ask each one, take the population. Anybody else? Yes, population, you said? Yeah, population. What about the average age of teachers in the U.S.? Sample, yeah, I'm not going to go through and ask everybody there. What about the average time spent texting by teens? Sample, yeah. Can't go through every teen and ask them. What about the average course grade for Mrs. Cucci's classes? Yeah, population. That's small enough. All my data is really accessible. All right. So keep that in the back of your mind, because you're going to have to remember, if we use a sample or if we use the population, you're going to have to look up both those symbols. There's the little O with the tail and the S. Both of those are going to be in that readout. And you're going to have to figure out which one you have to use. And we'll see that in a second. But we also have something called the variance. And the variance is It's pretty easy. All it is take the standard deviation and you square it. That's it. Just take that number that it gives you and square it. It also tells you how spread out the data is. And the bigger it is, the more spread out it is, the less accurate it is. But if they ask you for the variance, all you have to do is take the standard deviation and square it. Standard deviation is going to be the one that we're using in our other calculations and stuff. We don't use the variance for that. So let's take a look at this example. We have a car company, and they're trying to determine the fuel efficiency of a new car that they just designed. They take 50 of them and drive them. They record the data in the table on the next slide. We'll see that in a second. But first off, if they took 50 of them, drove them, and recorded the data, what did they use? Did they use a sample, or did they use the population? What was it? What do you think? What do you think, Brianna? So if you say the population, that means they took every car that they made and they drove it. They used the sample. Well, they're probably going to make more than 50 cars. I mean, if they're willing to do a study, they got the money. They're going to be doing more than 50 cars. They're not going to make their money back for 50 cars, so they're selling those. So we need to find the mean, the standard deviation, and the variance. Here's our chart. Now remember, take a look at the chart for a second. We have the fuel, I abbreviated, that's for fuel efficiency, so 37 miles to the gallon, 38 miles to the gallon, 39 miles to the gallon. Then cars, it should say number of cars. So we have 2 cars at 37 miles to the gallon, 6 cars at 38 miles to the gallon, and so on. What kind of chart is this? Cars would be the frequency, yes, exactly. Cars would be the frequency. So I've got this for you. How do I get my mean, my standard deviation? Where am I going to go? Open the calculator page. Keep going. Menu. 6. 1. 1. Number of lists 1. Yep. What's our X list? Our X list is our variable. What's that? That's the fuel, the mileage, the MPGs. And then we have a frequency. In this case, we have a frequency. We got to make sure we put that in there. Okay. So we get our readout. What's our mean? Our X bar, what do we get? 39.48. Remember, try and put the units if we're given units in the problem. This is miles per gallon. Right. And we also needed the standard deviation. Which standard deviation do I want to use, Steve? Which standard deviation do I want to use? Do I want to use SX, or do I want to use the O with the tail? Which one? Yep. S of X. Because why? What's S of X? That's the sample, yeah. We use the sample in this case, so we have to use a sample standard deviation. And what is it? Yeah, 1.09, yeah. 1.09 miles per gallon. Standard deviation and mean have the same units. If we would have worked through that formula, you could have seen that come out. Believe me. All right. We also needed the variance. What's the variance? We just said it. What'd you do? Yep, 1.09 squared, and you get 1.88. 1.188, yep. 1.188. And that's in, would they ask you a unit for the variance? For the variance, yeah. Oh, okay. Yeah. Yeah. So you don't need units for the variance, but I would put units for these two. Okay. So we have a mean of 39.48 MPG and standard deviation of 1.09 MPG. All right. Let's take a look at part B of this question. We want to know how many of the cars had a fuel efficiency 1 standard deviation below the mean. How do I find out what 1 standard deviation below the mean is? I have to subtract the sample from the mean. The sample? I think you screwed up the word. The sample standard deviation, yes. So I had to do x bar minus the sample standard deviation. So I'm going to get, my mean was 39.48 mpg minus my standard deviation. And I get what? 38.39. Yep, they're asking how many cars had a fuel efficiency below 1 standard deviation below the mean. So in other words, if I had, remember how I split up, I could say I could represent my data like this. Here's my mean, here's my x bar. Here's a value right here, x bar minus my standard deviation, right? We're asking what's below this dotted line. What's over here? What's on the real low end? So how many cars have a fuel efficiency below 38.39 mpgs? Look at your table. How many? 2. So 2 get 37 miles to the gallon. Hold on. Remember how to read the table. It's 8. Why is it 8, Stephen? Yes, there are 2. The number of cars, if you flip back to that calculator table, there are 2 cars that get 37 miles to the gallon. There are 6 cars that get 38 miles to the gallon. 38 miles to the gallon is still below 38.39 miles to the gallon. You're going to go further with 38.39 miles to the gallon. So there are 8 cars. 8 cars is my final answer for this question that are below 1 standard deviation below the mean. Okay? Now we have kind of the hot button question. The government, the EPA, they only allow companies to advertise a fuel efficiency if it's within 2 standard deviations of the mean when they tested them. Okay, we want to know, so can this company say that this car that they're testing, can they claim on the commercials that it gets 42 miles to the gallon? Okay, so what do we need to figure out? What do we need to figure out in order to answer that question? Well, we know the mean. We know the mean's 39.48. So subtract the standard deviation twice, or we could just do add and subtract 2 times the standard deviation. So we have our mean, 39.48, right? We want to know if it's within 2 standard deviations. If it's within 2 standard deviations, notice it doesn't say above or below, right? So we have to assume, we have to find that kind of range. So this right here, this high point is going to be x bar plus 2 standard deviations, right? So 2 times the standard deviation. And here is going to be the mean minus 2 times the standard deviation. What is 2 times the standard deviation? What do we get if we take 1.09 and multiply by 2? That was the square. There's a variance. Be careful with that. It's not, remember, 2 times the standard deviation is not the variance. The variance is this squared. Standard deviation. Multiply the standard deviation by standard deviation. What is it? 2.18. 2.18. We take the standard deviation of 1.09 and we multiply by 2. We want to be within 2 standard deviations. So we want to add this number to the mean. And? Okay, 41.66. What else do we need to find? well, they asked for between, so let's get practice doing this. What would we need to do? We need to subtract two standard deviations. So minus 2.18, and we get 37.30. Okay, yeah. All right. So that means that the range that we could be in is 37.30 and 41.66 miles to the gallon. Is 42 within that range? So can I claim that on the commercial? No, I can't. No. I cannot claim that it goes 42 miles to the gallon. But keep in mind, though, look at what this means, though. This means I could say that this car, when I found in the test, wasn't even 39.5 miles per gallon. It was less than that. I can actually legally claim that it's 41 miles to the gallon. Or over 41. Technically, I can say over 41 miles to the gallon on a commercial and still be legal. So see how you can kind of, statistics are whatever you interpret them to be, kind of thing. You have to keep that in mind when you're reading any type of those studies or anything. That's all they're doing for those studies and like commercials and stuff. They're just doing these base statistics, and you can kind of skew the results sometimes if you don't think about it. All right. So I think that's everything. Yep. Good job today. Remember, your homework is going to be pages 22 and 23 in the packet. We also have review class tonight. It's going to be trig operations. First trig. If you can't make it tonight, we're going to run the same review class tomorrow night. Choose your day. All right.